Hi everyone, today we are diving into 10 ways to hack OWASP juice shop. Before we begin, here are the team members involved in this project. For exploit 1, I will demonstrate administrative page discovery. This application relies on security by obscurity, meaning the developer merely hides the admin button from the navigation menu, assuming users cannot find the page. However, the underlying root remains active on the server side. By manually changing the URL path to hashtag administration and hitting enter, the application directly processes the root and grants me access to the hidden dashboard. This exposure allows anyone to leak sensitive customer emails and perform unauthorized destructive actions such as clicking this trash bin icon to successfully delete a customer feedback directly from the live database. The root cause is a missing access check on this path. To remediate this, developers must protect the root configuration using an Angular root guard, specifically implementing canActive admin guard to enforce strict rule validation. Moving on to exploit 2, which is insecure direct object reference on the basket page. While logged in, clicking your basket allows us to intercept the backend request via Birdsuite proxy. As shown here, my legitimate basket identifier is number 6. So by forwarding this request to the repeater, I can manually tamper with the resource parameter. Then I change my basket ID from 6 to a lower index like 2 and hit send. The backend database blindly processes the request and leaks sensitive JSON data belonging to a completely different user. The root cause is a lack of object level authorization within the root/basket.ts. So to remediate this idle flaw, developers must implement a strict server-side ownership validation barrier to cross-check the authenticated session identifier against the target database role before releasing any data.
With exploit 3, which is unauthorized admin registration, so as you can see, I already filled in the registration details and make sure the intercept is turned on, and then click register. So now we can see the data being intercepted. Turn the intercept off, and then the request is captured. So as you can see here, there is a role variable that we want to exploit. So we will send the request to the repeater, and we will paste the role customer that we copied earlier, and then we will change the customer into admin and click send. So it shows bad request, but we can still try logging in to check whether it worked. So now I will log in using the email that I registered earlier. So as you can see, the account now has administrator privileges. This code is insecure because user can change their role to admin by modifying the request. So to prevent this, we can implement this secure code that forces normal users to stay as customer, and only admins can assign admin roles. So we will continue with exploit 4, which is forge feedback. Here is the feedback page, and I will fill in all the details. So make sure the Birdsuite intercept is turned on, and then click send. And we can see the request is intercepted. After that, turn the intercept off. Next, search for the post feedback request. So here we can see the user ID parameter that we want to exploit. So send it to the repeater and modify the user ID. We're gonna put the value is 1, and then we're gonna click send. And then we're gonna click send, and we can see the request is successful. And now we can check the feedback again, and there it is. You can see here, this code causes the vulnerability because the backend trusts the user ID, so the attackers can submit feedback as another user. So to secure the code, we can use the request.user.id from authenticated session instead of user input to prevent identity forgery. Continue with our exploit 5, which is DOM XSS. So this is our OWASP juice shop. So I click on the search and I enter the malicious payload into the search bar and click enter. And it will pop up appears with the message XSS showing that the JavaScript code was executed successfully. So to verify this, I will open the developer tools using F12, and I will search for the XSS. So Here I can see the injected iframe tag inside the DOM structure, confirming that the payload was stored and executed in the page. This code causes the vulnerability, which is this code uses the bypass security trust HTML, so it will run harmful scripts. So to secure this, we can use this code, so it will assign the value and it will be treated as normal text and prevent XSS attacks. I will demonstrate on how can we access the confidential document. First, you're gonna click the green link that says check out our borrowing terms, and this trigger will request to the FTP legal MD file. So next, we're gonna open our burp suite and intercept the request, as you can see here, and I will send this request to the repeater tab, and we will open it, and I will modify the request by changing get FTP only. So after sending the request, I can see a directory listing of files stored in the FTP folder. So I'm gonna search for the acquisitions MD, and I'm gonna copy it and I will paste it here. This will show that the internal files are exposed without proper access control. This code causes the vulnerability because there is no authentication or access control to the directory. So to fix this problem, we should implement a server-side authentication so only authorized users can view the sensitive files through a secure API.
So hello guys, today I'm going to show you how I'm gonna do exploit number 7, which is matrix endpoint exposure. So what I'm gonna do, I'm gonna navigate to localhost 3000 matrix, as you can see here. So as you can see, the page loads immediately with no authentication required. It exposes sensitive server information including HTTP request counts, CPU usage, memory, consumption, and internal startup test detail. Looking at the source code, the serve matrix function has no authentication or IP check. It goes straight to serving the data. This one line, which is rest await register matrix, executes with zero security checks. So the fix that I'm going to do is add an IP allow list and authorize check before serving any data, rejecting all requests that do not come from the trusted internet system. This is a classic security misconfiguration vulnerability. Sensitive data exposed simply because access control was never implemented. So right now I'm gonna show you exploit number 8, which is coupon manipulation. Starting from the OWASP shop main page, I will navigate to FTP directory, which will have a coupon 2013 mdbug. But when I click it, the page is blocked. So what I'm gonna do, I'm gonna change the URL into the binary 2500 injection. And when I create it, there is a 5 full list of coupon here. Alright. Looking at the source code here, the apply coupon function has no authentication, no expiry check, no usage limit, no user binding. It simply decodes the coupon and applies the discount immediately. So the fix that I'm gonna do, I'm gonna add 5 server-side checks, which is verify user login, verify basket belong to login user, look up coupon in the database and expiry and usage check, check coupon not already used by the user, and lastly apply coupon and record usage. This fix adds to ensuring coupon cannot be abused. So this attack chain show how a single misconfigured directory leads directly to business logic abuse through coupon manipulation. Now I'm going to show you how I'm going to do exploit number 9, which is local storage inspection. Starting from the OWASP shop login page, I will navigate to DevTool, to the storage tab, which is at the storage we have a local storage, and we can see there is the containing full JWT authentication token stored in plain text, accessible to any JavaScript running on this page. So what I'm gonna do here, I'm gonna copy this code. So we go to JWT.io to fully decode the token that we get. So here we can see user email address, password, MD5 hash password, role, and user ID, all without any secret key. This is because payload is only base64 encoded, not encrypted. Looking at the source code, we can see two critical issues. First, password hash using MD5, which is cryptographically broken. Second, the private key is hard-coded directly in source file. meaning anyone with code access can forge valid token. So there is two feats that I'm gonna do here, which is the first one is HTTP only cookies for token storage, and second, bcrypt for password hashing, eliminating SSH token theft entirely. I'm gonna demonstrate to you aspect number 10, which is JWT manipulation. Starting from the browser local storage, I will copy the JWT authentication token that was stored after login and demonstrate how it can be manipulated to escalate privilege. So at here, I already pasted the token into jwt.io. I can see the decoded header showing algorithm RS256 and the payload showing the user email, role set to customer, and other sensitive data. Since the payload is only base 64 encoded, I can modify it freely. I will now change the role into from the customer into the admin directly in the payload. The token is automatically recorded on the left side, and then copy the token, the forged token, and inject it back into local storage using the browser console. Looking at the source code, the verify function uses jws.verify, which does not validate token expiry issues or audience. The private key is also hard-coded in the source, meaning anyone can study the signing mechanism and craft forged token. The feat is to use jwt.verify with strict RS256 algorithm whitelist, validate issuer and audience claim, and load the private key from environment variables, preventing any token forgery attempt.
Thank you for watching. We hope this demonstration helped you understand common web vulnerabilities better. See you next time.